Hey guys, and welcome back to this class, Data Science, Deep Learning in Python Part 2. In this lecture, we're going to take the basics of TensorFlow that we learned last time, and we're going to apply them to build a neural network in TensorFlow. So if you don't want to write this code yourself and you just want to check it out, go to github.com/lazyprogrammer/machine learning examples, and it's in the folder ANN class 2, and the relevant file is tensorflow2.py. So we're going to first do our usual imports. And we're going to use matplotlib to plot the cost. And we're going to use the same error rate calculation from the Theano example. Okay, so we're going to get our data as usual. And we're going to copy all this stuff from the Theano example up to there. So now for this example, we are going to add another hidden layer to our neural network. So we're going to make the second layer size 100. So now this dimensionality changes to D and M1. This will be M1 and M2. And then we're going to have another set of weights and biases. So this is M1, this is M2, this is K, this is M2, this is K. This is W3 and B3. Okay, and so now, as an analogy to Theano, we're going to create our TensorFlow variables and expressions. So X is a placeholder, so float 32, and you can pass in none as a length for the shape. And I'm going to create TensorFlow variables for all my parameters. And now I'm going to use TensorFlow functions to define my model. So the first hidden layer output will be relu mapmul x and w1 plus b1. The second layer output will be tf relu mapmul z1 and w2 plus b2. And I'm calling this output y-ish because it's not really y. It's just the matrix multiplication of z2, w3 plus b3 without doing the softmax, because the softmax is included in the cost calculation for some reason. So you can write the cost as reduced sum, and then we're going to call this weird function called softmax cross entropy with logits, and we're going to pass in our y-ish variable and the targets. And so we need our train and prediction functions, and we're going to pass in predict to get the error rate. So train op equals. So for this example, we're going to use the RMS prop optimizer, since we already learned about it. And as it happens, the RMS prop optimizer also includes momentum. So we're going to use both of these in the TensorFlow example. So you pass in the decay rate and the momentum, and we are minimizing the cost. And prediction is just the argmax on axis 1. Okay, so this stuff is probably familiar to you. We have our log likelihood array to plot our log likelihoods, and we initialize all variables, as you've seen already. We start our session. We run the init function, and then we have our usual for loop. I'm going to just grab that from the previous example. Okay, so in Theano we just call the function. In TensorFlow we call session to run the function. And we pass things in through the feed dict. So if we've hit our print period, we're going to calculate cost on the test data, as we've been doing. And we're going to run our prediction as well, so we can get the error rate. And we're going to print stuff out. So this is going to be test cost. This will be also test cost. And after all that's done, we're going to plot the log likelihood again. And that's it. So let's run this. Alright, so notice that our error rate wasn't really improved by adding this extra layer, but we still got a comparable answer. Also notice how the test error starts to increase after a while. So this might mean we are overfitting.